Welcome to Brain Vision.
So once again, we're given information on two figure skaters. So they're skating on ice. So this is the information that's given. We have figure skaters on ice, and they're excuse me, they're going to be pushing against each other. Okay, so they're going to be pushing against each other, and the one of them, the fast one, we're going to call him, A, and this one B. So the weight of A is given as 625 newtons, and then the weight of B is given as 725 newtons. That means the mass of A is 625 newtons over 9.8 meters per second squared, giving us, round about 63.78 kilograms. And the mass of B happens to be 725 newtons over 9.8 meters per second squared, not kilograms, but meters per second squared. So I'll change that. Meters per second squared. And so the weight, the mass of B is going to be 73.98 kilograms. So we're given, that's the information we're given. Also, we're told that the velocity of B, the initial velocity of B, so that's the velocity. When the final velocity of B. We're given the final velocity of B as having been 1.50 meters per second. Before they start, we're also given the initial velocity of A to be 0 meters per second. We don't know what the final velocity of A is, and that's what we're going to be looking for. We do know also that the initial velocity of B, the initial velocity happens to be 0 meters per second. So in part A, we want to find the final velocity of A once they make contact. They're going to make contact. So once they make contact, we want to know what's the final velocity of A. This is still A and this is B. And then also the other thing we want to find out is what's the total kinetic energy. Remember, the total kinetic energy will be the kinetic energy of A plus the kinetic energy of B. And remember, this encompasses both the initial kinetic energy of A plus the final kinetic energy of A. That's one part. The other part would be plus the initial kinetic energy of B plus the final kinetic energy of B. So I'm just going to change this to make things a little bit comfortable, to follow the same convention. We have to we have to follow some type of convention right here. So this would be A initial, and this is A final, like that. So this is the information we're given. This is what we're dealing with, and we want to see how it's going to help us find the final velocity of B, and then the final velocity of A, sorry, and then the total kinetic energy of the system. So in the next page, we start our problem, the steps in our problem. So uh, before collision, before they collide with each other, we have to think about the kinetic energy. So we have the momentum. This is the momentum. We have to find the momentum of A. Remember, our goal is to find the velocity of A, the final velocity of A. So the momentum of A, the initial momentum of A is the mass of A times the initial velocity of A. And this happens to be, if you go back, you see the mass of A is 63.78 kilograms. Okay, so 63.78 kilograms times the initial velocity of A, 0 meters per second. We also need to get the initial momentum of B, which is the mass of B, times the initial uh, velocity of B. And this is, if you go back, you see that the mass of B happens to be 73.98 kilograms. So this is 73.98 kilograms times 0 meters per second. And so you can see that the total initial momentum for both of them, okay, the total initial momentum for both of them, that's for A and B, is just going to be 0 kilogram meters per second. And that's the total initial momentum for both of them. Since for this one, the initial momentum for A is 0 kilogram meters per second, and then for B is also 0 kilogram meters per second. Remember, our target is the final velocity of A after they collide. So after collision, you get to see that the final momentum of A happens to be the mass of A. I forgot this subscript. This is A and this is B, and this is mass of A times the final velocity of A, and that's going to give us 63.78 kilograms times, we don't know what the final velocity of A is, so we're just going to put the variable there. And then we also need to find the final velocity of B. This is mass of B times velocity of B final, and this is 73.98 kilograms times, if you go back to the initial page, you get to see that the final velocity of B is 1.50 meters per second. Okay, 1.50 meters per second. This means that the total final momentum of A and B is just going to be the sum of all of these. So, combining PA final plus PB final. Just like we did here, the initial total would be PA initial, the momentum of A, the initial momentum of A plus the initial momentum of B. That's how it is. At this point, I think we're on the right track. So all we have to remember is we use the law of conservation of momentum, and we pick up that on the second page where we're saying that according to the law of conservation of momentum, so now we're looking at the law of conservation of momentum, and we're saying that the initial momentum of A and B together has to be equal to the final momentum of A and B together. And so this is 0 kilogram meters per second has to be equal to the final momentum. This is final of A plus the final momentum of B. The final momentum of A, you can recall, is 63.78 kilograms of VA final. 0.78 kilograms times final velocity of A. And then you could see that the final momentum of B is 73.98 kilograms times the final velocity of B, which is 1.50 meters per second. And so this turns out to be, we can shift things and see that the final velocity of A is the same as 73.98 minus, because this one is going to go to the other side. So we have a minus right there, kilogram, times 1.50 meters per second, all over 63.78 kilograms. And that leads us to the point where the final velocity of A happens to be negative 7.4, negative 1, sorry, gotta change this a little bit, negative 1 point, oh wait, okay, so I need to change this, so it makes sense. So this is negative 1, negative 1.74 meters per second. This is the final velocity of A. So that's the initial part of the problem that we've dealt with. The second part is very comfortable, because in the second part, all we're doing is we have to just go back to the requirement of B, and here we're computing the total kinetic energy, which is the same as the kinetic energy of A plus the kinetic energy of B. Remember, the kinetic energy of A becomes kinetic energy of A, the initial one, plus the initial plus the final kinetic energy of A, not B. I'm going to change the subscript again. So this is going to be the final. This is the final. We'll need to change that. So this is A final. That's the initial part, and then plus the same thing happens for B, the initial kinetic energy for B plus the final kinetic energy for B. And so this becomes the initial kinetic energy for A is 1/2 mass of A times the initial velocity of A plus 1/2 mass of A times final velocity of A, and then plus 1/2 mass of B, initial velocity of B plus 1/2 mass of B, final velocity of B. That's what we have here. Remember, if you go back, you get to see that for both cases, the initial velocities was 0. So this is going to be 0, and this one too is going to be 0. So it seems like the total kinetic energy is just composed of the final kinetic energy of the two cases, 63.78. That gives us our mass times the velocity of A final, which we computed in the previous section. It happens to be negative 7.4 meters per second, negative 1.74 meters per second. Just to recall that kinetic energy has to be squared, so don't forget that, it has to be squared. And so this is going to be squared plus 1/2 mass of B. We have to go back and check it, 73.98 kilograms. And then the final velocity of B is also given at the beginning. It happens to be 1.50 meters per second. If you do the math for that problem, you end up with what we're looking for, and that happens to be 1.8, 180, or 1.8. So this is 180 kilogram meters squared per second squared. That's the final total kinetic energy. I hope you enjoyed the problem. If you go back, you can see we picked up on the masses of the objects. And then we went on to notice that the initial momentum was 0, but then the final momentum was computed, and it was based on specific numbers. Your calculator will come in handy when you're solving those problems. So, like just multiplying the mass and the velocity to give you the momentum. And then once you get the momentum, you equate the initial momentum to the final momentum according to the law of conservation of momentum. That helps you solve for the final velocity of A. Once you get the final velocity of A, you just plug in and get the total kinetic energy. Remember, this minus changes and becomes a plus, so that's why the kinetic energy is positive. Hope you enjoyed it. Feel free to send out any questions, and thanks for watching. Okay, bye.